As Alan Kay once said, the best way to predict the future is to invent it. Well, ladies and gentlemen, I Arpita Priyadarshini, a 10th grader, and accompanying me are P. Kirtika, Ayush Pani, Anvesh Kumar Sahu, and Adarsh Sir. And together, we constitute Innovators United.
Across the world, agriculture depends heavily on water. Yet, in many regions, farmers still rely on manual irrigation methods that waste both time and resources. Water scarcity, unpredictable weather, and high energy costs make farming increasingly difficult.
That's where technology can make a difference. By combining automation, renewable energy, and mobility, irrigation can become smarter, faster, and more sustainable.
Our project is built around that idea. It's called Automatic Water Irrigation System using a Land Rover with solar power utility. It's a self-operating rover designed to detect soil moisture levels and deliver water exactly where it is needed.
The rover moves across the farmland using sensor to monitor soil conditions. When it finds dry areas, it automatically activates a pump to irrigate that spot. The entire system runs on solar power, which means it doesn't rely on external electricity and can operate even in remote locations.
We chose this project because water management is one of the biggest challenges in agriculture today. Farmers often waste water through over-irrigation, while others lose crops due to under-irrigation. At the same time, energy costs keep rising. We wanted to design a system that saves both water and energy while reducing human effort.
In short, this project shows how automation and renewable energy can work together to create a sustainable, efficient, and environmental friendly irrigation solution. Well, in many agricultural areas, water scarcity and inefficient irrigation are major problems. Farmers often waste water by over-irrigating or face reduced crop yield due to under-irrigation. At the same time, energy costs are rising and manual irrigation requires a lot of time and labor. So, we wanted to design a self-sufficient solar power system that saves water, saves electricity, and reduces the farmer's workload, and while promoting sustainable farming practices.
In summary, our project demonstrates how automation and renewable energy can work together to create an intelligent and mobile irrigation.
Now the question arises, why this project?
Nowadays, despite being an agricultural country, the number of people who die of hunger is still quite high. Access to food seems to be difficult as price and quantity of food is still beyond the capability of the lower middle class and lower class. Irrigation-induced crop failure is a major cause of crop loss every year, and in the age of water crisis, this has been elevated to greater levels. In order to keep up with increasing demand, farmers are required to increase crop efficiency by rapidly advancing technologies.
In order to handle irrigation issues, this system has been devised and implemented. Usually, farmers need a large-scale manpower to irrigate the large land simultaneously. However, Automatic Plant Irrigation System (APIS) is an automatic system that facilitates automated irrigation of lands simultaneously upon need.
We believe this innovation can make a real difference in modern agricultural society by improving efficiency, conserving resources, and supporting sustainable growth. Thank you.
Now, let us shift our attention towards the working of this project.
This project consists of two sections, the external sensor unit and the inbuilt processing unit. In the external sensor unit, the basic requirement of sensing the moistness of the sand or soil through capacitive reactance is performed. The arms of the sensor are able to detect resistance.
When the soil becomes dry, it produces large voltage drop due to high resistance, and this is sensed by the soil moisture sensor, and the resistance causes the operational amplifier to produce an output that is above the threshold value required.
This causes the relay to change from normally open to closed condition. The relay becomes on. When the relay is turned on, The valve opens and water through the pipes rushes to the crops.
When the water content in the soil increases, the soil resistance decreases and the transmission of the probes starts to make the operational amplifier stop the triggering of the relay. Finally, the valve which is connected to the relay is stopped.
OP-amp is configured here as a comparator. The comparator monitors the sensors, and when sensors sense the dry condition, then the project will switch on the monitor and it will switch off the motor when the sensors are in wet conditions. The comparator does the above job when it receives the signals from the sensors.
A transistor is used to drive the relay during the soil's wet condition. 5-volt double pole double through relay is used to control the water pump. LED indication is provided for visual identification of the relay or the load status. A switching diode is connected across the relay to neutralize the reverse EMF.
This project works on 5-volt regulated power supply for the internal blocks and uses regulated 5-volt power supply for the relay board. Power on LED is connected for visual identification of power status.
First, the sensor probes are inserted in the soil at specific locations in the field at a depth of 5 cm from the soil surface at regular intervals in the field. The wiring is made with 23 protective coverings so that it is not harmed by any unexpected factors like rocks in the field.
Since wet soil is more conductive than dry soil, the soil moisture sensor module has a comparator in it. The voltage from the prongs and the predefined voltage are compared, and the output of the comparator is high only when the soil condition is dry.
When the moisture in the soil is above the threshold, the relay will be turned on. The relay coil gets energized and turns on the motor. The LED is also turned on as an indicator. The soil begins to get supplied with water and the water content of the soil increases.
When the moisture content of the soil increases and receives to the threshold value, the output of the soil moisture sensor is lowered and the motor is turned off. This prevents a case of overwatering.
The entire model is mounted on a Land Rover chassis. It contains DC gear motors which provide the required torque to move through soil and uneven farm surfaces.
The motion is transmitted through gears that increase torque and ensure smooth movement. We also use dummy wheels for balancing and weight distribution so the rover remains stable on rough terrain.
The rover can be controlled manually using a joystick. When the joystick is tilted in any direction, it sends signals to the microcontroller or the motor driver.
This allows autonomous navigation, sensor-based decision making, data recording, and selective irrigation, making the system suitable for smart agriculture.
The rover runs on rechargeable battery packs which supply power to the motors, sensor module, and control electronics. The battery ensures uninterrupted operation in the field.
A solar panel mounted on top recharges the battery during the day. This eliminates dependency on external power sources and reduces operational cost.
The rover can further be equipped with IR or ultrasonic sensors to detect obstacles, preventing damage to crops and components. This improves mobility, safety, and accuracy while patrolling the field.
Thank you guys, that sums up the working of the prototype. Now Anvesh will come and explain the future plans for this project.
Thank you.
Thank you.
Now, I'm Anvesh Kumar Sahu here to say a brief about our future plans. This project takes a step towards that future where smart, renewable and automated system makes farming more efficient, sustainable and accessible for all. Our project already demonstrates how automated irrigation and solar powered mobility can make farming more efficient and sustainable. But this is the only beginning of what we envision. With additional support, we aim to enhance our system with two key innovations. The first is a detachable seed planting unit that allows the rover to plant seeds in a straight rows with precise spacing and depth using mechanical pistons. This would ensure that The seeds are not eaten by the birds and are neither affected by the elements, for example, wind. The second is an automated fertilizer spraying device that ensures even a consistent distribution across the entire farm by utilizing the characteristics of soil like the pH levels. Uneven fertilizer spray is a common issue when done manually, and this system would help solve that by maintaining accuracy and reducing waste. In future, we also hope to integrate AI-based analysis, crop monitoring, and predictive irrigation systems, turning our rover into a complete smart farming solution. With the right grants and partnership, this project could evolve into a technology that truly empowers farmers, saving time, conserving water, and improving productivity sustainably.
Now we have come to an end of our presentation. In conclusion, our project combines automation, renewable energy and smart technology to make farming more efficient and sustainable. By integrating soil sensors, automated irrigation and a solar-powered rover, we have developed a system that adapts to field conditions while conserving water and energy.
From a technical perspective, the rover is equipped with moisture sensors that constantly monitor field conditions. These sensors send real-time data to the control system, which then activates the irrigation mechanism only where and when it is needed. This rover's solar panels provide a clean and renewable energy source, powering both movement and irrigation systems. Its modular design allows attachment of future units such as the seed planter and fertilizer sprayer, making the system highly versatile and expandable.
One of our main goals is to reduce the heavy dependency on manual labor that still exists in the agricultural sector today. By automating key farming tasks, we aim to make agriculture more convenient, accurate and accessible, especially for farmers with limited resources or workforce.
Looking ahead, our planned additions such as the detachable seed planting unit and the automated fertilizer spraying mechanism will make our rover a complete smart farming solution.
With further development, funding and support, we believe this project has the potential to transform traditional farming into a modern, sustainable and technology-driven practice. Ultimately, our vision is to build a future where technology and sustainability work hand in hand to improve productivity and empower farmers.
That's all. This is Innovators United signing off.